que no haya mucha diferencia. Con el vídeo tú puedes hacer una
Hola, buenas tardes a los que estáis conectados. Muchas gracias por venir hoy. Vamos a dejar unos minutos para quien se haya retrasado y para las personas que van a venir presenciales a la escuela. Y en breve empezaremos la charla. Muchas gracias.
Bueno, eso ya se va a acabar pronto. No te preocupes. Bueno, al final tenemos una compilación súper antigua. Llevamos las incidencias, no les merece la pena migrar, ¿verdad?
Buenas tardes, Enrique.
Todavía veo empresas que piden que vuelvan.
Hello, James. Thank you for coming today. Can you hear me?
Yes, I can hear you. Thank you so much.
Thank you very much. Okay, well, thank you everyone for... Muchas gracias a todos por venir a esta charla. Como sabéis, el ponente de hoy, James Jackson, aquí presente en Londres, es un líder tecnológico con más de una década de experiencia en IT y en ciberseguridad. Y nos va a guiar a través de los desafíos y oportunidades que presentan los modelos RAG. En la charla va a analizar las limitaciones de las arquitecturas actuales de generación aumentada de recuperación y compartirá un enfoque innovador que ha estado diseñando él para mejorar la precisión y la eficiencia en la generación de informes. James, además, es miembro fundador del equipo de respuesta a incidentes en SRM, la consultora de ciberseguridad en la que trabaja en Londres, y ahora mismo es el líder en integración de inteligencia artificial en su trabajo. De nuevo, muchas gracias a todos y doy paso a James. James, whenever you like, you can start the talk.
Great, thank you so much, and thank you everyone else for joining me today. So, in terms of what I will be talking about today, this is roughly the agenda. So I want to walk you through an AI case study where I've been using sort of LLMs to complete what I'm referring to as a complex analysis task. And in order to help deconstruct the problem there and you know, evidence why this has been valuable and to share some lessons learned with you, I'll basically walk through what I set out to achieve with this implementation, what the problem is we're trying to solve with it, what the solution ended up looking like, and then what are some next steps and applications of the project. And before I do any of that, however, I will briefly introduce myself and hopefully provide you with some reasons why you should listen to me at all. So my name is James Jackson, and I currently work for a company called SRM. We are a cybersecurity consultancy and corporate intelligence provider. And over the last 6 years, this team that I'm part of has grown from basically a small company of 70 people to over about 350 people globally now. And the big piece of work I did for them was found their incident response function. Now, when I joined SRM about 6 years ago, my main contribution was on the technical side of the business. So I helped build systems designed to handle terabytes of forensic data. At the time, 6 years ago, ransomware was very new, and this is primarily what we were dealing with. And the systems I was building just simply didn't exist. So a big part of my role was building real-time data systems. These days, however, I work primarily on the advisory side of the business and have a special focus on technology and transformation, but particularly and increasingly on AI. And before SRM entirely, my background was basically entirely non-technical. I started out by doing a Bachelor of Arts with a double major in English literature and history, but IT was always a bit more of a natural fit for me. Now, I started off doing systems administration work, which went into networking, and then I got more involved in software engineering, which is what introduced me to security. And once I sort of got into security through penetration testing or offensive security, that took me through forensics, incident response, and now into my sort of advisory role. So combined, I have about 10 years of experience across IT and cybersecurity. And there isn't a lot in this industry that I haven't done. But what's really exciting with AI is it has been an opportunity to basically blend the non-technical side of my career with the technical. And it's been really exciting to combine them for the first time. And so what I want to do is basically set out and explain a problem that we've been trying to solve with AI and how we've gone and done that. So I'll start by talking about what did I set out to achieve. So the problem we're trying to solve here is report generation. Now, I work in a consultancy, so we churn out complex assessments every single day. And the assessments or the analysis that we churn out are in the formats of reports. And a report could be anything. A report could be a geopolitical question, like, is a country going to develop nuclear weapons? It could be a financial question. Should I invest some money in a sector? Could be government focused or policy focused. What is the threat to a renewable energy industry? Or it could even be a cybersecurity technical question, like what was the root cause of a security incident? These are the reports that we sort of write every day. And what I observed is that writing reports costs the business money. On average, we spend about 30 to 40% of any project reviewing data and writing reports. The reporting process alone takes about 5 working days to deliver. And all in all, this can cost organizations about £1,500 in human labor. So it costs money to produce reports. And this is also taking away your most experienced analysts, the people who have the insight and technical skills to advise on a particular problem out of circulation because they're writing reports, they're not consulting, they're not researching. And so the theory was here, can we use an AI to emulate the way that humans actually write reports? And when we broke it down, any report generation basically involves 3 quite simple steps. It involves research, which is where we simply collect relevant information, we review it, and we might annotate it and we say, this is relevant, this is not so relevant. We then take that information and we conduct analysis. So this is where you need your specialized expertise, but we take our research materials and we use it to answer key questions. Once we've done all that, we then report on the results of our analysis with justification. And so, again, the theory was, can we just take this quite rudimentary process and get an AI to do it for us? The first step we had to do here was define what even is a report, because we can't do report generation without actually thinking about what are we trying to achieve here. So the definition of a report that we came up with is basically that reports are a unique literary form. And I use that word, literary here quite explicitly. Although reports are nonfiction, they are presenting data, they are much more like creative nonfiction because any good report will have a narrative flow to it where you have to walk a reader through a complex argument. I use an example of, for example, like an analyst writing a report on the viability of a nuclear fusion reactor. You know, this might be a highly technical report involving nuclear physics. And although it might be aimed at a technical audience, you never know who's going to pick up that report. It could be a government minister or an investor or someone like that. And they need to understand, without being technical, what the information is you're trying to convey. And this is really key to what a report is. They're trying to communicate complex information to a variety of audiences. And in terms of how they do that, they basically utilize 3 techniques. The first is that they present information in a structured format. So reports aren't just free text. They're not just a dump of information on a page. They walk you through different sections. So there is often an executive summary in a report. There might be a finding sections. There will probably be appendices and footnotes and endnotes. And these are all different types of ways of presenting structured information in a literary form. Style is also really important to reports, and vocabulary is a part of that. If you are writing any sort of research paper that involves assessing risk, for example, you might be using words like probably or likely to describe whether a risk is going to occur or not. Now, these are not the same word. You have to define a corporate vocabulary to what those actually mean, and you can't just chop and change between different sets of words. And so the way you present that information and the words you use is incredibly important for writing reports. And basically, LLMs are really bad at this. You know, an LLM doesn't intuitively understand that the word likely is not the right word to use here, and we should be using the word probably. It doesn't quite understand that because it doesn't understand your corporate vocabulary. And so we thought, basically, if we want to make it so that LLMs can actually do this, we need to start right at the bottom, and we need to think about, can we get LLMs to conduct research? And this basically means that we define all the unstructured information that goes into our reports. This could be meetings, it could be workshops, interview transcripts, emails that you've sent back and forth, pitches, documents, slide decks. Any snippet of information that's going to be relevant to your end report needs to be captured as part of a research phase. The next phase, we need an analysis engine. So we need the LLM to basically be able to inject specialized expertise to review our research body and then answer the key questions that are going to be used to generate the report, which is the final step of the process. This was basically the objective that we set out to achieve of this project. So Teresa, I don't know if you want to ask if there are any questions at this point.
Bueno, como habréis podido observar, yo estoy aquí un poco para mediar y aclarar cualquier duda que surja. Entonces voy a hacer un pequeño resumen de lo que ha explicado ahora mismo James, y si hay alguna pregunta o algo que queráis que se aclare o que os aclare, estoy aquí para traducir. Entonces, básicamente lo que nos ha explicado es que el objetivo principal de este proyecto es mejorar el proceso de creación de informes en el ámbito de ciberseguridad y IT, en su caso, utilizando inteligencia artificial. En la actualidad, los analistas expertos dedican entre un 30 y un 40% de su tiempo a revisar datos y a redactar informes, lo que suele llevar alrededor de, estima, unos 5 días de trabajo y tiene un coste significativo para las empresas. Y esto impide que los analistas se concentren en tareas de mayor valor estratégico, si tienen que estar simplemente escribiendo los reports. Entonces, el objetivo de este proyecto de James, dentro de SRM en concreto, es implementar un sistema de inteligencia artificial que pueda emular, utilizando el lenguaje corporativo y las sutilezas del lenguaje que utilizan en estas empresas, específicamente la jerarquía de términos, que utilizan las personas que están detrás, los que investigan, analizan y reportan, lo cual implica recopilar, revisar, anotar información relevante, analizar los datos, responder preguntas clave y finalmente presentar respuestas justificadas de manera estructurada. Entonces, el proyecto que está dirigiendo ahora mismo James tendría más o menos ese objetivo: empezar a crear IAs especializadas desde la base, desde los datos no estructurados, pasando por el proceso que nos ha explicado, la investigación, el análisis con input de expertos y, por último, que se cree automáticamente el reporte estructurado. ¿Alguna pregunta sobre esta sección? ¿No? No hay preguntas. Muy bien.
Okay,
James,
I'll move on to the next section.
yes.
So once we had basically defined what we're trying to achieve here, the next thing we had to do is understand why we couldn't just go off and do this off the shelf. There are a number of reasons why this was the case. And the first thing that sort of anyone thinks about when they're doing an AI project these days is, can we just use RAG? So just to make sure everyone's on the same page about basically what RAG is, RAG is an acronym, stands for Retrieval Augmented Generation. And effectively, there are 3 steps to implementing RAG as part of an AI project. The first step involves getting all your unstructured information. So in our case, everything we wanted to use for our research, we get in one place, we chunk it, which basically means that we chop it up into individual portions, and we index that data in some sort of database. That's step 1. Step 2 is your user will query that information, and using some sort of process, it doesn't particularly matter what process you're using, but using some sort of process, your RAG implementation will retrieve what it believes are the most relevant results from your index data. So we call this top K results, just indicating the top, for example, 10 most relevant results. And it reviews all your index data for that information. It retrieves the relevant chunks, and it will inject it into your model's context. Now, in reality, there are basically 3 main types of RAGs that are used right now. There is something as simple as keyword search. If you're making a query, for example, where your user query could be, where does a certain celebrity live, for example, and it's simply using that keyword to search your index data and retrieve any information relevant to that keyword. One that's a bit more popular these days is something called graph RAG, which is basically using a specialized type of database to try and map and index your data a little bit differently. You have semantic RAG, which is where you take your chunks and you turn those chunks into numeric representation through a process called vectorization, and you're using that to inform your knowledge retrieval, search. There is a 4th method, which is hybrid RAG, which is where you're basically combining all these different types. The details of this don't matter too much. Needless to say, basically what's happening is you're making a query and information is coming back. And that information is then used to inform your model response. Now, for some use cases, this is really effective. So in this simple diagram here, this is a very simple high-level diagram of a user asking a question such as, how many days of leave am I entitled to per year? So imagine they're asking this in a corporate AI solution. All that's happening here is that query is being passed along to the RAG implementation, which could be any of the previous methods I've just described. That query is then being used to search the index and rank relevant documents. And in this case, there are 2 databases queried, a policy database, which might include all the organization's HR policies, for example, and an article database, which might be their internal blog or news platform. And that RAG implementation has basically found 2 documents that it thinks is relevant to that query, the HR policy and an internal news article that's talking about an update to the leave policy. That information is simply being grabbed, injected into the LLM, and then the LLM is issuing a response. Now, in this case, this is really effective because information is being identified, the right information is being identified, and it's being used to inform a model response. This is how it works at the moment. However, this model or this sort of implementation is basically not suitable for the use case that we're trying to solve here. We have a number of key issues. So the first issue we have is not being able to retrieve all the relevant data. this is a real challenge. So when we're writing reports and we have to gather research data, we could be talking about millions of contexts worth of information. A great example is if you are, let's just say you're an anthropology student or some sort of historian, and you're going and interviewing people around the world about their life. And let's just say you interview 1,000 people. That could be absolutely millions of tokens. If you're asking your RAG implementation a question, such as, what was this person's name? Or can you recall a fact about an interview that happened? You basically cannot guarantee that the right information will be retrieved, because you don't know how the RAG implementation is going to work. And this is a real big problem. One example that we have in cybersecurity a lot is if I am talking to an organization about their control estate, and I'm asking them what endpoint protection software do they use, what antivirus software they use, they might say to me, okay, we're using Fortinet or any product, but Fortinet is an example. And they might say the word Fortinet over and over again in a meeting. After the meeting, they might email me and say, sorry, James, I said Fortinet before, but actually we're using CrowdStrike. Now, if I'm indexed that information and I ask my LLM what endpoint protection software are they using, it's probably going to tell me Fortinet, because it's not going to understand the correlation between CrowdStrike and endpoint protection. And we can't guarantee ever that it's going to pick up that information. So automatically, just from that point alone, RAG is not suitable for the research use case. But the flip side of this problem is sometimes you get too much data back. So let's just say we're worried about retrieving too little information, and so we expand top K. So instead of retrieving the top 10 results, we retrieve the top 1,000 results, or the top 10,000 results, or however many results we're talking about, to increase our chances of getting the information we want. All that happens now is you saturate the context window of your LLMs, and all LLMs have limitations on the number of tokens that they can review at any one time. If you give them too many tokens, basically two things happens. You introduce what is called decoherency, where AIs and LLMs start to hallucinate and they start to forget what you've asked them. But number two is they will often just not reply. If you give them too many tokens that can fit within their context window, they're physically unable to give you a reply. And so for some use cases, going back to my example about the anthropologist that is interviewing people, if I have 1,000 interview transcripts and I want to ask a question like, which one of the people I interviewed is the richest person? In order to do that, the LLM has got to review every single transcript and make an assessment, a judgment, that's the analysis part, on who it thinks is the richest person. But in order to do that, it needs to take all the information into the model context. And it can't do that because now we're talking about too many tokens. And so for those two reasons, the traditional RAG implementations that we have in the industry are not viable for research tasks that involve reviewing all this information. It would be unthinkable, for example, if a client or an organization received information that you didn't review. If you're an analyst and you are undertaking research and someone handed you a document, you have to review it. But with RAG, we can't guarantee that that will happen. And so that is a major issue that we had to overcome here. Now, I'm going to put a pin in that for now and talk about the second issue we have with report generation, which is the formatting of the report. So we have an issue with the research where we can't retrieve the information using RAG, but also we have to be able to control the output, because as I talked about at the beginning, the output of report is really important. We need to be able to control how we're presenting information. And typically with LLMs, we have three ways of doing that. We can prompt it. We can say, we can give it information about how we want the output to be published. Very simple example, you're a writer, write me a poem. It could also be, you're a nuclear physicist, explain how this nuclear reactor works. But we can give it a prompt and we can use that to instruct it on how to format the output. We can do something called multi-shot generation, which is the second example, which is where we give the LLM an actual example of what we're trying to achieve. Rather than tell it, we just say, here's a previous report, try to replicate that. And then the third option we have is fine-tuning, which is where we show it examples of what we want to do. So we might give it 20 previous results where we have the input data and the output data, and we just say, I want you to do this. But again, there are issues when we come to think about our use case here. Number one is that LLMs have a finite number of output tokens they can publish. So with GPT-4.0, the latest, or the most recent, the most relevant model from OpenAI, it's limited to producing an output of 4,096 output tokens. It can't write more than that. And so if you want your report to be longer than that, you have a real problem there. The second point is that I mentioned at the beginning that reports present structured data. And at the moment, LLMs are really only capable of writing plain text. And so we need a way of being able to identify that structured information. We want the LLM to produce the executive summary with the footnotes or the appendices as discrete individual sections of a report, rather than just write a plain text report. That's not particularly helpful here. And then the third problem, which was a bit of a surprise to me, because I had assumed, working for a consultancy, that we would have lots of historical reports that we could fine-tune off. For most organizations, that's not the case, because in order to fine-tune data, in order to fine-tune a model, you need the input information. So all this research or documentation that we need that to train a model, because all you're doing with fine-tuning is saying, here's your input and here's your output. But no one is keeping notes from 5 years ago or interview transcripts. If you're having an in-person meeting, for example, that's often not recorded. And so most organizations are in a position where they can't make these fine-tuned models because they don't have the original data. And so we had to solve this problem. And we basically came up with a quick way of helping us do that. And it involved basically coming up with this data schema, which is what you're seeing on the screen here, where we have a way of instructing the LLM on how to produce a report of the desired format. So effectively, for every report we want to onboard onto the system, we basically define sections. And on the left, we have a simple plain text section. And a section, in this case, could be an executive summary. So we know that our report needs a section called executive summary, and we are able to provide a prompt for that section and an example of a previous executive summary. And a report can have as many sections as we want, because every report is basically, every section is its individual output within the LLM. So our end report can basically be as long as we need it to be. The second schema we developed was how to instruct the report to provide structured findings. So a great example of this is if you're doing a cybersecurity audit. You could be using any framework you want, NIST, CSF, CIS, or basically whatever you want. And you typically have a section of your report that says findings, and then you might have 50 findings underneath that section. And all of those findings present structured data. Every finding has a description, an impact, and a recommendation. And this second data model is basically how we were able to instruct the LLM to produce information in that format. Just like before, we start with a prompt and an example, and then we say that we need every output to basically have those 3 bits of structured data, the description, impact, and recommendation. And we can use that to guide the LLM to produce a structured report. And so this basically is how we solved the issue of report structure. But we still had one significant problem, which is that we, regardless of the fact that we could control the output, we still lacked the ability to fine-tune off historical reports. And this was basically the major issue when it comes to report structure. So Teresa, I don't know if you want to summarize from there.
Yes, of course. Aquí James nos ha estado hablando de la definición del problema, y el problema que él describe se centra en las limitaciones del método RAG tradicional. nos explica que aunque RAG puede ayudar a procesar datos no estructurados y generar respuestas basadas en la búsqueda de información relevante, presenta dos problemas principales. Uno sería la falta de datos suficientes. Nos explica que en ocasiones no se recupera toda la información necesaria para dar respuestas completas y complejas, lo cual lleva a respuestas imprecisas. Y otro de los problemas sería el exceso de datos, puesto que a veces el sistema recibe tanta información que esto supera la capacidad del modelo de inteligencia artificial para manejarla de manera efectiva, porque el número de datos excede el límite de tokens del modelo. Entonces, James presenta pues, o explica la necesidad de un método que garantice que toda la información sea revisada y utilizada por la IA, incluso cuando el volumen de datos supera el límite de procesamiento de la herramienta, que es lo que nos explica aquí. Sin embargo, sigue puntualizando que obviamente si no tenemos suficientes datos para poder, digamos, hacer que el sistema produzca reportajes sutiles, porque no tenemos suficiente información histórica, por ejemplo, las reuniones que no se han grabado o simplemente información o reports que ya no maneja la empresa, pues no se puede entrenar al sistema de forma efectiva. ¿Alguna pregunta al respecto de esta sección? Sí, dinos.
Esta parte, no sé si lo entiendes o te lo digo a ti y se lo traduce.
Como tú quieras, si se lo quieres preguntar directamente. Ah, bueno, igual no me oye. Vale, dímelo a mí.
En esta parte, que lo que se encarga es en encontrar una estructura a cada uno de los reportes, lo que se me asemeja a mí es a una especie de skill set, que le está añadiendo al LLM con metadatos internos para no dañar el tamaño del contexto que le va a meter al LLM. Entonces, esta parte de estructurar los descubrimientos, los findings, ¿está hablando de un skill set o está hablando de otro tipo de formato, el cual también va a entrar dentro del contexto? Eso es lo que...
Vale. James, okay. This question pertains to parallel that the student here has found between your model or solution and the concept of a skill set. So he wonders whether what we're introducing here is an added skill set that adds to the capacity of an existing AI model to sort of like structure the data. ¿Cuál es la otra palabra que has usado? Yeah, with metadata. Or if what we're using here is something different to this concept of skill set. ¿Sí? Más o menos.
So, I think that question will become apparent when I move on to the next section and present the solution and what we've done here. Effectively what we're doing is building a new method of RAG, so a new method of retrieval. And so the way you tag an index document, so by defining document metadata, is still really important, but that is part of the solution that we've created in this space. Effectively, we are building guardrails or frameworks that guide LLMs towards reporting in a certain way, as well as conducting the analysis and the research. So I hope that makes sense for now, but I think you'll find more detail about that in this next section.
Sí, para quien no haya entendido, dice que sí, en efecto, esto es parte de la solución. Cree que en las siguientes diapositivas se explicará esto mejor, pero básicamente lo que están haciendo es crear un nuevo modelo de RAG que utiliza lo que llama guardrails, como lo que tienen las escaleras para agarrarse, sí, básicamente, para dirigir mejor los resultados que produce la IA. Pero que en efecto lo que mencionas es parte de la solución. Sí, en efecto, y lo explicará ahora. Thank you, James.
Okay, great. So basically, this next section is presenting the solution that we came up with to address the problems. So recapping, basically two problems we're trying to solve. The first is that the traditional methods of RAG were not effective for conducting research and analysis because we can't guarantee that they actually review the documentation. And the result is that you get knowledge loss. And that's unacceptable when you're trying to write reports on a particular subject area. The second issue is that we were unable to fine-tune models, and without being able to fine-tune, we couldn't instruct the LLM basically on how to write reports in the way we want to. We could control the output and the format of the output, but we couldn't teach it how to conduct the analysis. And the solution that we came up with here is something I've dubbed researched RAG. So it's a different method of RAG implementation. And the best way to describe it is I say basically it is an attention-based process that's applied specifically to research-heavy workloads. So it is designed for these research situations where you might have millions of tokens. It's not designed to answer small, simple questions like, what is my HR policy, or what is the weather like tomorrow? It is basically designed to guide LLMs towards providing complex answers to questions with cited sources and low knowledge loss. And the big sort of invention that makes research RAG so effective is that we are condensing information from our research data into a structured data schema. Unlike every other type of RAG, you typically ask your questions after you've indexed your data. With researched RAG, you define your questions before you index your data. And this makes all the difference in the world. Effectively, what we do is we create a questionnaire in advance of any report where we define all the questions we want to answer and how we want that answer to be presented. So in this example here in the box, you can see we're asking one very simple question: what's the client's full name? I need to know that answer in order to write my report. If I'm writing a cybersecurity report, as in this example, another question I want to know is what EDR products are they using in their environment? Now, I need to know the answer to that question if I want to write my report, and I'm defining that in advance, so before I've done any indexing. And this basically means this is actually a really useful process because it means you have to think about what information is actually necessary to my report writing in the first place. And it ensures that we're not going to miss information that traditional RAG would have missed entirely, basically. There's a couple of additional benefits to research RAG. Unlike every other type of RAG, we sort of satisfy our key requirement to do complete document review. So we can guarantee with researched RAG that every single document that you submit to the index is going to be reviewed and analyzed against your questionnaire. So if there is any information in that document that answers a key question, it will be answered, it will be captured, and other RAG systems can't do this. The third benefit, which is, again, a really key part of this, is it allows us to fine-tune on reports where we don't have the input data. So like I explained earlier, most organizations aren't storing the data that they've used to write reports and so cannot fine-tune models. We can use researched RAG to bypass that requirement. And the reason why is because we're defining this data schema, which what we're saying is this is the information you need to answer to write the report. Now, it turns out the report that you write, often not by coincidence, will answer those same questions. So what you can do with researched RAG is you can provide the end finished report as the input documentation to answer the questionnaire, and then use the questionnaire to fine-tune on the report output. Now, it's not ideal, but what it means is that you can seed a very effective fine-tuned model from day zero, even without onboarding any other types of reports through the system. So it means you can take all your historic data and you can make a really effective model, a really effective reporting AI LLM, even if you don't have that input data. And then the fourth point is these questionnaires that we're storing are structured data. So for every project that we run through ResearchDrag, we now have access to information about that project. So in this example here, for example, I'm asking a simple question about what EDR products they're using. Now, if I deal with 1,000 of these reports every year, I now have structured data about what EDR products our customers are using in a simple database that I can query. And that's really valuable information that I can use later for industry insights or further analysis or research. And I don't have to do anything apart from define the questionnaire. So these are the 4 things that ResearchRag helps us achieve. Now, there are some limitations, 2 in particular that are quite relevant. The first point is it's expensive. And when I say expensive, I don't mean it's too much to bother with. What I mean is that it's more expensive than using LLMs off the shelf. This is because we're using really intensive processes that involve high token use to basically ensure that the analysis gets done. Now, even though it is more expensive, we have to bear in mind that the business case that I started with basically had that £1,500 limit. That's how much we currently spend on human labor writing reports. This implementation is expensive, but we're talking more about £100, for the AI. So vastly more expensive than what you might use with ChatGPT or anything like that, but considerably less expensive than the cost of human labor, especially if you're able to get it up to a similar standard, which we are with ResearchDrag. But that is one limitation to bear in mind. You shouldn't be using this if you're not making money off your reports, basically. And the second limitation is like I've explained, you have to define a data schema, and that is quite labor intensive. It means for every single report that you issue or you want to publish, you have to go in and define a data schema. And I've onboarded a couple of report types into the system, and the average number of questions is about 45. So you have to go in and you have to really think quite carefully about what questions do I want to answer. And that does take time, it takes effort, and it takes expertise. I'm not too worried about that, to be honest, because in the future, I think you'll be able to automate that data schema creation, but you have to do it right now. But regardless of all of this, the result is that we can actually achieve what we set out to achieve, which is reports that present complex information with low knowledge loss. Just breaking down the process a little bit further, just to illustrate how ResearchDrag works. Basically, step 1 is very similar to what we would do with regular RAG. We get all our information, all our research information, and we put it into an index, and we define the questionnaire that we want to answer. Basically, what happens is every question is then reviewed against your input documentation, and a composite document is created. So effectively, imagine that when I was doing my history degree, for example, what I would do is I would go to the library and I would get a big stack of books, 20 or so books, and I have a question that I want to answer. It could be anything. It could be, was Elizabeth I a good monarch, or was Shakespeare a good writer? It could be absolutely anything, but I have a research question that I want to answer. What I do then is I go through all of those books and I just highlight information that's relevant to that question. And then I take all that information and I put it in a notes document, and I use that to write my report. That's exactly what ResearchDrag is doing here. It is skim reading every document that you submit to it and highlighting the relevant information to your question. It's putting all of that information in a single document that we can then use to answer the question. So in this step 2 example, we've got 3 different documents, a transcript, a LinkedIn search, and a letter of engagement. And the LLM has extracted quotations from each of those documents that are relevant to the target question, which in this case is, what is the client's full legal name? And it's reviewed all of that information, and it's got a very simple answer, right? Its name is Acme Incorporated Limited, also known as Acme. That's a very simple use case, but the questions can be very complex. The questions can be, what is the company's cybersecurity strategy for next year? It could be absolutely anything. And bear in mind, you can define as many of these questions as you want. Like I said, the average is about 45. So it can answer all of those questions in a way that's guaranteed to understand all your input data. Then in step 3, all the answers to your questions are combined and outputted into a single questionnaire. So we have every single answer presented in a single data schema. That questionnaire, the answer to that questionnaire, is then what we use for report generation. So this is the big step of research drag. We have guaranteed now that all our input data is reviewed, and we have condensed it down into a list of questions and answers. And that list of questions and answers can then be used to generate the report. And this is how we bypass the token limits, because we can now effectively guarantee that no matter how many input tokens we have, we can condense it down to a series of questions and answers that can fit inside our context window and be used to answer and generate a report. That's effectively the research drag process. Now, there are a couple of additional considerations that we can use to enhance this. So one implementation, for example, that's really good is to use what we call small language models. So if you think about it, we are providing effectively a number of questions that we want answered. We can actually fine-tune individual, very small LLMs just on answering a particular category of question. So what that means is you develop a mixture of experts model where you might have an LLM that is very, very effective at assessing how a company manages cybersecurity risk, or very effective at understanding penetration testing results. And that's all they do. But because we have these questions and answers and we run reports through this process on a regular basis, we have the information to fine-tune these specialized SLMs. This has a lot of advantages because it is more complex infrastructure to set up, but it's actually cheaper than OpenAI because the models that we're running, you can run these on models that are sort of 6 billion parameters. They're tiny models, but they can be specialized to do a single thing. And roughly the process looks like this, where we load our document into context, we extract all the questions, all the strings relevant to the question. So that's the composite document we looked at earlier. And we end up with this combined input documentation that contains all the information to answer our question. The best model to answer that question is then selected from the mixture of expert swarm and the questions answered. And this, of course, goes through a fine-tuning process every single time so that we develop that mixture of experts that is the best at answering a particular question. And this leads to much better analysis and research at the end of the day. The second, or the last consideration we have is how to evaluate model effectiveness. And we've actually built a capability to do that as well, where we can basically chart the what we're referring to as the linguistic drift between a generated report and a human-authored report, which is considered a good baseline report. And the way we do that is frankly very simple. It basically involves taking a number of linguistic features from our reports and plotting that on an array with some machine learning involved as well. But the result is that we can basically prove that as we fine-tune the model, we can get better and better and better at emulating our human output. And this screenshot on the screen is a real example of how we've done that. So 0 is a perfect score. If you get a 0, that means that your report is identical to a human authored version. And as you can see on the left-hand side, we started off with an untrained model that was very, very high. There was significant linguistic drift between the generated report and the human report. But after a few generations of fine-tuning, we can actually get very, very close to a human-authored report. And the quality here is actually very good. But what I do want to show you is basically an example of what I'm talking about. So what I've got here is, it's quite difficult for me to show you a complete report because, reports can be 20 pages long. So instead, I'm just going to show you an example of an executive summary. And I'm going to show you what ChatGPT does versus what this research RAG process can deliver. So this particular executive summary was written for a cyber due diligence report. And the intent of the report was to advise a buyer who was trying to buy another company about the cybersecurity risks that were present in that company. And so what I've done is I've used the GPT-4.0 model with one-shot generation. So that's providing it with an example. And I've used the same prompts as I've used in Parchment Profit. I realize I haven't said that word before, but Parchment Profit is what we're calling the solution. And we basically, I can show you an example of how the 4.0 model does it compared to what we can do with Research RAG. So this is what GPT-4 was able to achieve off the bat. So we basically took all the information that we gathered for this particular project, anonymized the data, put it into ChatGPT with prompting, with an example, and it came up with an executive summary that looks like this. Now, I'm not going to go through it in detail, but I'm just going to highlight a couple of key points. So the first thing it says about this target organization is that Acme has a foundational IT infrastructure in place. Now, this isn't an assessment. This isn't providing any value. This might be context or background, but really that sentence or that clause could be relevant to every single company on Earth. So why is it said that it's not relevant? It's highlighted that there are several critical areas requiring enhancement. Well, yes, but I have questions. What? How critical? If I'm getting a report that says you have critical areas, to me, I'm thinking, crap, do I need to drop everything and fix this? But this report doesn't say that. It just says there are critical areas and then basically leaves you alone to figure it out for yourself. The rest of the report is all factually accurate, but again, so what? In this example, the company that we assessed here for this in this example generation, Acme, has been operating for years without issue. So when we do a cybersecurity report that says you have critical areas, what does that really mean? Are you just saying that the company has somehow survived for years based on luck? If it's not luck and there really are critical areas that need addressing, do I need new investment? How do I justify that investment? How soon should my timeline be? All of this is completely unanswered in what we get off the bat. And this is why, what I said about at the beginning, that LLMs are just frankly terrible at providing analysis. So I'm going to contrast that to what Parchment Profit came back with. And so this was using the research RAG process that we described, where we used the same questionnaire that we delivered for ChatGPT. And basically, we see some significant differences. So the very first paragraph doesn't just say there are critical areas. It says there are gaps in the organization's cybersecurity governance, which makes it vulnerable to unassessed and uncontrolled risk. Compared to what ChatGPT was saying, this is now relevant, focused, and actually tells me what is wrong with the company. Specifically, their governance is not reviewing risks that it should be managing. That just tells me immediately what's going on here. The next paragraph summarizes the impact of that risk by saying that there is a high risk of them experiencing a major financial loss event. And in particular, it doesn't just summarize, what the impact is, but it explains the exacerbating factors. So it says that the impact of this incident would be made worse because of the absence of cybersecurity insurance. So they're going to suffer a major incident, and it's going to be worse because they don't have any insurance. They don't have any way of transferring that risk. It's then gone on to explain the compensating factors and said, despite this, they actually have backups in place, and that's likely to be sufficient to avoid total data loss following a major incident. So you can see here how, like I said at the beginning of this presentation, this is walking me through a narrative. It's basically a work of creative nonfiction here. It's walking me through bit by bit the information I need to know to form a complex assessment. It started by saying there's a really big problem. Well, there's an issue with this particular thing. Then it said this particular thing is a major problem, but there are things that make it less worse. And now it said why those issues are occurring. So it's particularly said that This is happening because the company lacks the resources to adequately manage their ongoing security requirements. And it specifically calls out the absence of dedicated information security roles. So it's explained why this is the case. And this last paragraph, which I actually think is a really good example of why Research RAG has been so successful, is it's provided recommendations on how these issues can be addressed and fixed. And unlike what ChatGPT did, it's not just a bullet point list of waffle. It basically says, you know, if you implement the recommendations outlined in this report within 100 days, then you would be able to downgrade our impact from a high to a medium. Now, this is really significant because in the world of cybersecurity, if I'm writing a report that says you're at a high risk of something, that's a big deal. You know, people lose their jobs over getting a report that has red high risk over it. So this is saying, yes, there's a high risk, but the Research RAG process has basically identified that we should be telling clients how they can downgrade that risk immediately to a medium, basically to stop people getting fired, you know, to stop people coming under immense pressure. And it's saying that if you implemented those recommendations, you can get that score down. So hopefully that's a good example of what I'm trying to talk about when I talk about the process of Research RAG. This is the type of output that we can get when we apply this process. And it should be evident that this is vastly different to anything we can get out of ChatGPT. This type of report is client ready. You know, I would be happy for this to go straight to a client. Bearing in mind, it's just an executive summary. There's more of this report that's also generated, but this is the value that it's providing. And then just quickly to end, basically, I'm just simply describing the process of putting it all together. If you want, feel free to take a photo or a screenshot of that. But this is effectively how the process works in totality, where we're going from identifying a reporting requirement straight through to the mixture of experts model, and then eventually through to the report generation, including the fine-tuning that's captured at the end of that process. So if you wanted to take a photo of that, please do. But that's what the process looks like end to end. And other than that, that really brings me to the end of what I wanted to discuss today. A couple of points to end on. If you want to understand more about Research RAG, I do have an article online that goes into much more detail. That includes some relevant examples. It includes diagrams, pictures. So if you did want to delve into the technical details, please have a look at that article because it does a lot better job at explaining what it actually does. And then, you know, just because you are all interested in AI and may have applications for Research RAG or may have projects of your own, you know, please feel free to connect with me on LinkedIn. I'm always happy to talk about AI with anyone who has questions, or I'm very happy to support and advise you on your own projects as well. So, you know, please feel free to do either of those two things. And other than that, we can end with some questions, basically, I think, if there are any.
Sure. Thank you, James. If that's okay, I will provide a tiny summary of the last
Sure. Yeah.
the last issues you've been talking about, just in case there are any doubts or queries. So, voy a intentar resumir rápido las últimas secciones de las que ha hablado James. Básicamente nos ha definido el problema, que son las limitaciones del método tradicional del RAG, y nos cuenta que aunque el RAG puede ayudar a procesar datos no estructurados basadas en información relevante, bueno, hay dos problemas principales. De esto ya hemos hablado, pero bueno, para recordar cuál es el contexto. Entonces, la solución propuesta es un enfoque que James ha llamado Researched RAG, que sería como RAG investigado. Este método mejora el proceso de RAG utilizando un enfoque de investigación más riguroso. Básicamente diseñan las preguntas en las que se tiene que enfocar esta inteligencia artificial desde el principio y revisa toda la información disponible en base a estas preguntas. James estima que el proceso de delineación de estas preguntas es bastante trabajoso y requiere mucha experiencia y mucho expertise, y de media para generar un report con los que lidia él en su trabajo serían unas 45 preguntas. Entonces, los pasos son definir este cuestionario, hacer que el modelo analice los documentos completamente y básicamente utilizar este back and forth, o sea, esta misma lista de preguntas para digamos, generar más precisión en el proceso, como, digamos, una revisión de las respuestas. Entonces, este método básicamente hace que se tenga en cuenta todo el contenido relevante y la IA o el RAG no ignore nada. Entonces, los siguientes pasos que nos explica James son continuar optimizando y mejorando este modelo de Research RAG. Lo que él propone es utilizar modelos de lenguaje pequeños en vez de modelos de lenguaje grandes, los SLMs, que pueden ser más económicos que las soluciones actuales, incluyendo ChatGPT, OpenAI, y en algunos casos incluso más efectivos. Otra consideración sería monitorear y evaluar la efectividad del modelo a lo largo del tiempo para comprobar que las respuestas son precisas y útiles, y sugiere además la formación de un sistema basado en la mezcla de expertos, the mixture of experts, que combina varios modelos especializados para obtener respuestas más claras a preguntas más complejas. Y estos modelos, bueno, pues como todos los demás, se entrenarán para condensar la información de manera efectiva, ofrecer unos resultados o un enfoque más eficiente y, sobre todo, rentable para la generación de informes complejos. Algo muy relevante a las empresas que ha explicado James es que sí, este nuevo enfoque es más caro al principio, requiere más inversión, pero a la larga sale más barato que el capital humano. Y esto sería la mayor contribución del modelo, pero también enfatiza el hecho de que si uno no gana dinero con estos reports que genera este tipo de research RAG, entonces no tiene mucho sentido invertir en ello. Tiene sentido para empresas, consultoras, tipo SRM, donde trabaja él. Y además os invita a leer el artículo que ha escrito sobre su modelo de Research RAG, Parchment Profit, perdón. Y a conectar con él en LinkedIn si queréis hablar sobre IA, si queréis comentar vuestros propios proyectos con él o si queréis información adicional. Y ahora vendría la ronda de preguntas y respuestas. Muy bien. James, you have a question here in the chat. It's in English already. Did you try with GPT-4o using assistance with instructions, RAG, and advanced prompt engineering, like a tree of thoughts?
Yeah, I see the question. So, yes, exactly. So these methods are still unsuitable because even with custom instructions, that's just prompting. Advanced prompt engineering, tree of thought, these are just prompting methods. At the end of the day, we can't use those to control the output in the way we wanted. So we had to develop an API integration with the structured data for the report schema that I outlined earlier in the slide. And that allowed us to control the report structure. But the bigger problem is the RAG, because the RAG cannot retrieve the information we need to make research decisions and conduct the analysis. So even if you can get some of the way there with, with custom instructions and prompting, because we are using that in research RAG, but the problem is more around the data retrieval. We need to be able to get the information condensed into that questionnaire format so that we can then prompt it. The other big thing to point out is that, if we go back to the example I shared about the output, even with the best fine-tuning, even with the best prompt engineering in the world, you're never going to get an example like on the right-hand side, because this has custom vocabulary that has been fine-tuned based off hundreds of reports, and the fine-tuning has to be a critical part of that process. So there are limitations basically with the off-the-shelf solution. The solution that we've invented is that combination of being able to fine-tune, and the ability to fine-tune is because we've invented research RAG. So that's what we've added there. We are still using prompting as part of this, but it's not sufficient to provide the solution that we're looking for here.
Etcétera, etcétera. También dice que ellos también utilizan sistemas de prompting dentro de este modelo de RAG, pero que el hecho de que hayan conseguido un resultado tan relevante y específico pasa por el hecho de que se ha creado este primer cuestionario que enfoca la cuestión y ese cuestionario se utiliza después para el fine tuning. Por tanto, es mucho más acotado y requiere mucho menos tokens, según entiendo. ¿Alguna pregunta aquí? ¿Sí? Sí, claro, yo traduzco.
Hemos hablado de una serie de KPIs sobre costes efectivos de kilómetros, tiempo de saber los informes, y un poco el coste. Pues habla del coste a corto plazo, el coste a largo plazo, ha hablado un poco rentable para más de cierto tamaño.
Sí.
Eso, o sea, ¿cómo comparamos ahora los datos iniciales y si implementamos los tres sistemas? ¿Cuál es el ahorro? ¿Cómo se traduce? ¿Cómo convencemos a nuestros inversores para que nos dejen la pasta y nos ayudamos en esto?
Muy bien, buena pregunta. Esto creo que le interesa pensarlo. James, the next question is about the business model and the KPIs you mentioned at the beginning. The student here is wondering, how do we present the case to potential clients that want to buy this system? How do we compare data that exists nowadays? The numbers you cited, pretty much like that, the actual cost, the amount of hours, human labor, level of expertise, etc., with the value of the output that this creates, right? So what is the business case, pretty much? Like, can we make a prediction of how both compare? What would be like the main incentive for companies to hire or to like pay for this service?
Yeah.
And yes, basically what is the business model?
Yeah, so I've implemented Research Dragon a couple of use cases so far. In one particular product, which is the CyberDT product, which is this example on the screen. Since implementing this, basically, we have consistently delivered 30 to 40% under budget on every project that we've delivered. So immediately, through doing nothing but basically running AI through the system, we have saved 30 to 40% of our budget. Now, that's including the cost of the AI generation as part of an expense on that project. So the business case, I think, here is really quite compelling. Now, the economics of this are complicated because it's a bit of a race to the bottom. As soon as other companies start to become AI assisted, then suddenly everyone's prices drop. So although there is a very compelling business case now, and there are opportunities to basically demonstrate business savings, it's not entirely clear that that will be the case in the future. I think what is clear, though, is that regardless of what happens, you would be sort of there is a significant opportunity cost by not incorporating AI reporting into your business models right now, because you won't be able to compete with them in the future.
Lo que dice es que ya ha hecho varios test runs, varias pruebas de implementación de este sistema en su propia empresa, y dice que para los dos casos que están finalizados ha conseguido constantemente entre 30 y 40% digamos, de reducción de reducción de costes por debajo del budget, del presupuesto. Entonces, básicamente, se han ahorrado un 40% frente al presupuesto. Esos son los resultados que han obtenido hasta ahora. También dice que este proceso es una carrera hacia el fondo. Básicamente, cuando las empresas empiecen a implementar este tipo básicamente de inteligencias artificiales personalizadas para su caso, los costes se van a abaratar, etcétera, etcétera. Entonces, bueno, pues para poder vender estos servicios, pues básicamente habrá que competir con todos los proyectos que aparezcan en el mercado, pero cree que es importante para las empresas darse cuenta de que cuanto antes implementen estos sistemas, aunque ahora sean más caros, por ser pioneros, antes empezarán a ahorrar costes en el negocio. No tendrán que competir más tarde con estas automatizaciones cuando se vuelvan más extendidas, creo. Okay. The next question pertains to your... Oh, no. Yeah. What is... Okay. The first question is in English, so you can probably read it. Would these LLM models based on research RAG be similar to OpenAI's GPT agents that are trained with proprietary documentations?
Yeah. So the answer, if I get the right slide, roughly is no, it's not similar. So OpenAI GPT agents are basically still just invoking what you might refer to as the traditional RAG process, which is what I outlined here. So they are using a combination of these models that are presented in step 2. Most of them, I would say probably 70% of anything that's using RAG right now is using semantic RAG. So when you take a GPT agent and you point it at your Wikipedia base, your wiki base, or your knowledge base, or your code base of GitHub, all it's really doing is using one of these RAG methods to retrieve the information like that's illustrated here and then give you an answer. Now, for some use cases, it's absolutely fine, works really, really well, but it's not able to be used with this particular report process because we have these issues here. We either use the agents and we can't guarantee that the information we get is accurate, or even that they've reviewed the documents that we wanted them to review, or it retrieves too much information that it can't usefully answer the question. So that's why Research RAG has been very specifically designed. It is filling a capability gap that, as far as I'm aware, no one has implemented yet. I could be wrong on that, but I haven't seen anything.
I have a follow-up question here, though. If you do create your own GPT on the platform that ChatGPT provides and train it with your own data, would one be able to use this methodology you described of first laying out like a questionnaire and then feeding it the information and then fine-tuning it and like as a final step and finally generating a report? Or does their programming system not allow for this?
So, I mean, roughly what you're describing is sort of what we've done here, because there are 2 steps. There are the knowledge retrieval, which is the research RAG process, and then there's the fine-tuning process. So that's effectively what we've done, and we've orchestrated that in the framework. Now, you can't do that natively within ChatGPT right now.
Okay.
So you can't actually fine-tune within ChatGPT. You can use the APIs and you can fine-tune manually, but what we've built with this solution is a way of orchestrating that work. So, you know, we're using OpenAI to deliver these LLMs, or we're using the small language models that we host on site. But we haven't, you know, invented any new type of LLM here. We're just using existing methods on other providers. What's important is the way we have orchestrated that in a framework to solve this particular problem.
Okay. Básicamente no es lo mismo que utilizar los GPTs específicos de OpenAI, ni siquiera entrenarlos o crear uno propio con tus propios datos. Utilizan otros proveedores que ya existen, no han creado un sistema nuevo per se, y hacen la combinación de la que he hablado de LLMs y SLMs. A ver, siguiente pregunta. Next question is, someone is not sure what is your LinkedIn profile. There are many. What are they supposed to look for?
I think that if you scan the QR code, that should be the best way to find it.
Yes. James pide que si queréis llegar a su perfil específico de LinkedIn, lo mejor es escanear el código QR. Eso debería llevar directamente. Funciona.
De
Muy
todas
bien.
formas, a partir de mañana estará subida el vídeo en la página de actualidad en VIP
Sí,
y tendremos los enlaces también.
perfecto. Mañana estará subido el vídeo con los enlaces y bueno, James estará etiquetado. De hecho, James está etiquetado en la publicación original en LinkedIn de Envip de este evento, entonces solamente hay que darle clic a su nombre. Okay, next question. Earlier you said that one of the problems of RAGs is the limitation of the input tokens, but with the next big language models, I understand that these limitations will disappear. Do you agree?
Yeah, it's a really interesting question. And you're absolutely right that context windows are getting bigger all the time, and that trend will continue to happen. There are a couple of things I would say about that, though. Point one is that even if they get much, much bigger, they're still never going to be big enough. Depending on the type of project, like it is absolutely not an understatement to say you're dealing with tens of millions of tokens. It just depends what your project is. And so there will always be requirements to have more tokens than the model can support, regardless of how big they get. Secondly, all the research shows right now that bigger context models perform worse. The more information you give LLMs, the more decoherent they get. And so basically, yes, you might have an LLM that can support 5 million tokens, but that doesn't matter if they now hallucinate and they become decoherent and they can't stick to an output. So even if they did exist, and they probably will in the future, the evidence points to them not being as effective as we think they might be. The third thing is that even if you do have really effective models, there is still value condensing the information into a question and answer format. So what we found when we were testing researched RAG is we basically did what you've described. We simply found a project that had less than 1 million tokens, and we used it directly with Claude or Anthropic, where we were just able to put the entire documents in the LLM. The results we got was significantly worse than when we used research RAG to provide a questionnaire in a question and answer format. And frankly, the answer is because with the questionnaire process, with the data model, we are condensing tokens into relevant information for reporting. And that critical step provides much better output because we've put in the effort to basically focus the model on what it needs to report on. So it's a fantastic question. It's very relevant. My honest answer is I don't think it's particularly relevant. I think research RAG is still going to be a future-proof solution in this space because it has demonstrated that it performs better even under large context, even as context windows get bigger, basically.
Básicamente, James explica que el hecho de que vaya a haber modelos que permitan más tokens, esto no va a necesariamente generar los resultados que se buscan con Research RAG. Nos ha explicado antes que cuanta más información se le dé al modelo, más probable es que el modelo alucine o empiece a ser incoherente. Entonces, él entiende que, pues sí, aunque una de las problemáticas que ha identificado es que no hay suficientes tokens, el hecho de que vaya a haber más tokens no va a solucionar el problema de que los reports que queremos generar sean concisos y relevantes. No sé si me estoy dejando algo. Sí, bueno, James sí dice que sí, está de acuerdo. En efecto, van a existir estos modelos en el futuro cercano que permitan gestionar más información, pero su conclusión es que la necesidad de un RAG personalizado como el Research RAG va a seguir existiendo, precisamente por estas problemáticas asociadas a los modelos más grandes. Gracias. Next question. How often and at what error percentage does the research RAG system typically recalibrate based on errors? This is very technical.
Another really good question. It's a slightly complicated question to answer. And if I go to these examples to demonstrate my point here, in both of these examples, right, they look very different, but factually, there is no factual inaccuracies in either of these examples. the value that we've provided with the research drag system is basically to control the output and to make the output more consistent with our reporting style and language and narrative. So tracking errors is not necessarily the best metric here, because in actual fact, hallucinations, like straight factual errors, are extremely rare with this system. This is why we spent time crafting out this evaluation version on the left-hand side. And we're not looking at errors here. What we're looking at is that linguistic drift, because we care less about what the information is and more about how the information is presented. And that's what this is tracking. And it is an evaluative process. You know, typically, if you're writing reports in an enterprise, you will draft a report and then you will edit it. And so even if your report is AI generated, it will probably still be edited. And so we intend to track metrics like number of edits required to finalize a report and things like that. That's still in the works. But basically, the version that we have at the moment of measuring linguistic similarity, I think, is the best indicator we have. But all the evidence points that if there are sort of errors, it's extremely low.
James explica que los errores como tal no son la mejor métrica para medir cómo de efectivo es este sistema, porque considera que los modelos de lenguaje existentes, los más extendidos como ChatGPT, no cometen tantos errores de facto, o sea, no se inventan tantas cosas, no alucinan tanto. Lo que ellos utilizan como métrica de éxito aquí es cómo de preciso es el lenguaje, cómo de similar a los reports que escriben ellos, o sea, que las personas, los analistas escriben, cuánta es la desviación en el caso en que no sea exactamente igual. Y bueno, pues básicamente la medida más precisa de cómo deficiente es este proceso es cuántas ediciones hacen falta sobre el documento generados por la IA para que ese report esté listo para enviar a cliente. Si hacen falta muchísimas rondas de edición, pues está generando peor output, y si hacen falta muy pocas rondas o ninguna, está generando mejor output. Pero no es tanto los errores de facto. Como ha presentado al principio, al final con lo que estamos lidiando es como con un nuevo género literario, el report. Entonces todo tiene que ver con la sutileza del lenguaje, con el uso de ciertas palabras frente a otras, los grados, sobre todo en industrias como ciberseguridad, donde, como nos ha explicado, una palabra u otra puede digamos, puede hacer que un equipo entero desaparezca o a alguien se le eche o una empresa decida sobre la compraventa de otra o no. Esto es lo importante. ¿Hay más preguntas? ¿No? ¿Hay más preguntas aquí? ¿Sí?
Este rack se da un uso para el tema de ciberseguridad. Un uso concreto para hacer reportes de ciberseguridad.
Ese es solo el ejemplo y donde lo están testando. Sí.
Ciertas interacciones casi con la misma persona, con un servicio, ¿no? Durante su historia.
Sí.
Y eso permite pues, mejorar aplicaciones, soluciones y demás que nos cuestan una pasta, ¿no?
Ok. Buena pregunta. James, our student here is asking whether you have tried this new method in contexts that are not related to cybersecurity. For example, user experience or costly processes that require hundreds of interactions with, for example, clients.
Yeah. So the applications so far are well beyond cybersecurity. Like if I go back to the first slide, we are basically looking at questions like this on the right here. So the goal with Research Drag is to provide a general purpose analysis engine where you might require intelligence. So the focus is on strategic issues like, you know, if you had a cybersecurity attack or you want cybersecurity advice, or if you're in geopolitics or in the financial services. This is the main application we have so far. We haven't yet trialed it in other use cases. Frankly, I'm a little bit less interested for starters because I think there's enough work to do just in this area. But the idea is certainly not to just be cybersecurity. We want to be general purpose intelligence, basically, on any question you could ask. We're trying to replicate the human role of an analyst at the end of the day. And so if you're an organization that employs analysts, then we want to be able to mimic their processes. That's the goal here.
Básicamente todavía no han hecho ningún estudio extensivo en otras industrias, porque bueno, lo que le interesa ahora mismo, le ocupa y donde más información tiene es de su propia industria, pero desde luego el proyecto tiene cabida en cualquier tipo de empresa que requiera reportajes con consideraciones estratégicas o de inteligencia y que utilice perfiles de analista. Y creo que eso es todo. Creo que nos hemos extendido un poco. Hay una más. Okay. Last question. Do research RAG systems, when using LLM models, have a weakness in mathematical tasks compared to text generation tasks? How would you improve the performance in mathematical aspects of the report?
Yeah. So this is obviously a known limitation with all LLMs, and that there have been considerable advances to this, but it really comes down to two things. There's a level of fine-tuning involved in simply handling numbers sensibly, which a lot of LLMs weren't able to do initially when they came out. But mostly what happens is there is a second LLM reviewing the output of or the input of an LLM and trying to grab numbers and then format that in a way that can go to a script that can compute or calculate those numbers. So when you see sort of mathematical equations being written in ChatGPT and it's able to compute calculations, that's very rarely not the LLM that's doing that. It's a third-party process that the LLM is querying. It's almost like, reverse RAG. It's an action. It's outsourcing it to a third-party system. And we use that in the research RAG process. So if we're looking at, for example, financial analysis tasks, as an example, you're dealing with a lot of numbers. It's important that we don't treat those numbers as text. We treat them as numbers. And so we have the capability to add subsystems that can understand when numbers are present and extract that information into numeric format. And the applications of that are much beyond maths, because maths is a great example, but you also have examples like a family tree, right? If you've got a picture of a family tree, how do you pass that information and how do you represent that as structured data? That's a really key component of what research RAG is able to do. Now, it's difficult and it's incremental because you can't solve all of these problems in one day. But when there are problems that are specific to a use case, we can onboard a new way of taking that data out. So broadly, we have the tools to be able to do that. It's just a slow process to deploy and support everything that is out there, basically.
James explica que incluso los modelos de lenguaje más utilizados ahora mismo utilizan third-party systems, o sea, externalizan toda la parte que lidia con la parte numérica y las matemáticas. Entonces, ellos básicamente en su Research RAG hacen lo mismo, tienen la capacidad de integrar estos sistemas externos para lidiar con cosas relacionadas con, por ejemplo, informes financieros y demás. También cita el ejemplo de cómo el Research RAG analiza datos estructurados, por ejemplo, un árbol genealógico, y cree que la integración de los modelos matemáticos y modelos de lenguaje, además de los avances que proporciona el sistema Research RAG, realmente mejoran cómo este tipo de datos se analizan. I hope that was accurate. ¿Hay alguna pregunta más en la sala? ¿No hay más preguntas? Muy bien. Pues, first of all, thank you very much, James, for this talk. We went a bit over time, but I think that's a really good measure of how successful this was. It was super interesting, and I thank you personally and on behalf of MBIT School for being here today with us. Y también quiero agradecer a todos los que habéis venido aquí a la escuela y los que os habéis conectado online, todas las preguntas interesantes que se han hecho. Y por favor, me gustaría que le diésemos un aplauso a James por su ponencia.
Thank you all very much. Pleasure to be here.
Creo que ha sido increíble y muy informativa. Y bueno, nos gustaría tenerle en la escuela en otro momento para ver cómo evoluciona el proyecto. We would love to have you at the school at a further stage to see how this project progresses and how we can learn from you.
Yeah,
So yeah, muchas gracias a todos y damos por terminada la sesión.